Hi everyone, notes 5.5 are on proving trigonometric identities. This is day 2. So we're going to prove three identities right here. So the first one that we have is secant to the power of 4x minus 1. So the first thing I'm going to do is I'm going to rewrite this as 1 over cosine to the power of 1, or to the power of 4 minus 1. So 1 over cosine to the power of 4x minus 1 is equal to, and then on this side right here, I can see that there is a sine squared x in common. So if I can factor, I'm going to factor as best as I can. So I'm going to say this is equal to sine squared x, and then when I take it out, I have a 1 plus cosine squared x right here. And that's all over cosine to the power of 4x, okay? All right, so now for this side right here, I'm going to find a common denominator. So my common denominator is going to be cosine to the power of 4x. So I'm going to multiply both numerator and denominator by this. So I end up getting 1 minus, here I get cosine to the power of 4x all over cosine to the power of 4x. And here that's going to be equal to this value right here. Now, the reason why I got a common denominator here was because I noticed this whole side on the right side has cosine to the power of 4x in it. So I'm going to get my whole left side to have a denominator of cosine to the power of 4x. Okay? So now that I've done that, I still want my left side to look like my right side. And on my right side, I have sine. So I'm going to get rid of sine somehow. So if I know sine squared x plus cosine squared x is equal to 1, then I know that sine squared x is equal to 1 minus cosine squared x. So here I can say 1 minus cosine squared x times 1 plus cosine squared x. And that's all over cosine to the power of 4x. Now, you probably can see how they're the same thing. So you have two options. You can either FOIL this right here, or you can factor this. It's up to you. As long as both sides look the same, you've got the right answer. So I'm going to factor this difference of perfect squares that I have here, and that's all over cosine to the power of 4x, and that's equal to exactly the same thing that we have on this side right here, all over cosine to the power of 4x. So we've proven it and we're good to go. Okay? All right, so now let's take a look at number 2. In number 2, it says tan of x plus cotan of x. So I'm going to change everything into sine and cosine. So I'm going to change this to sine of x over cosine of x, plus this is going to turn into cosine of x over sine of x. And this right here, the 2 stays in the numerator because it's 2 times cosine of 2x. So I'm going to put sine of 2x in my denominator here. Okay, then I'm going to get my left side to get a common denominator. So my common denominator here is going to be sine x cosine x. So I'm going to multiply the left fraction by sine x over sine x. I'm going to multiply the right side, the right fraction by cosine x over cosine x. So this right here turns into sine squared x. This turns into cosine squared x, and that's all over sine x cosine x. And then on the other side right here, I end up getting 2 over, and if we use our double angle formulas, we know that sine of 2x right here is equal to, sorry about that, 2 sine x cosine x. So we can say that this right here is equal to 2 over 2 sine x cosine x. Now looking at this right here, I can see my 2's cancel, so I get 1 over sine x cosine x. And I also know that sine squared x plus cosine squared x is also 1. So I get 1 over sine x cos x is equal to 1 over sine x cosine x. And I've proven both sides of my identity to be true. All right, the last one that we have is in question number 3. And same thing, I've got tans and cotans, so I'm going to change them into sines and cosines. So right here, tan squared x means sine squared x over cosine squared x. And cotan squared x means cosine squared x over sine squared x. And then on the right side right here, I end up getting sine squared x minus cosine squared x all over sine squared x cosine squared x. So now a lot of people will see, oh, there's a cosine squared here and a sine squared here. That can get put together, but I can't because I need to get a common denominator. And even though my common denominator here is sine squared cosine squared, I can't just put these together. So I need to actually do my multiplication. So here I'm going to multiply this by sine squared x over sine squared x. And over here I'm going to multiply this by cosine squared x over cosine squared x. So I end up getting sine to the power of 4x minus cosine to the power of 4x all over cosine squared x sine squared x, which is the exact same denominator that we have here. Okay, so then I see that this is a difference of perfect squares, so I can factor this as sine squared x plus cosine squared x times sine squared x minus cosine squared x. And that's going to be all over cosine squared x sine squared x. So then taking a look at this right here, I can see that this number right here ends up being just 1. So it's 1 times sine squared x minus cosine squared x all over cosine, and I'm just going to change the order around so it matches the other one, sine squared x cosine squared x. So then 1 times any number is the same number, so sine squared x minus cosine squared x all over sine squared x cosine squared x, and that's exactly what we have right here. So I can say equals sine squared x minus cosine squared x all over sine squared x cosine squared x. I'm just going to bring down an arrow to show that those are the that went down for every single line, and I've proven, so I'm good to go. Now, one thing I just want to make sure you guys are aware of is there are several ways to prove an identity. So just because I showed you one way to prove this identity for any of these questions, 1, 2, or 3, doesn't mean that it's the only way that works. And if you find a different way that you would prefer to use, totally fine. That's the beauty of this stuff, is that you can do this any way you want as long as you're following algebraic properties and you're not breaking any rules, and you get both sides to be the exact same thing. You're going to get you'll prove it. So that's all that matters. All right, that's it. Let me know if you have any questions, and I hope you have a great day. Bye.